Hi everyone, good morning. Uh, Welcome to our session on end-to-end security automation with Terraform. My name is Vinay Venkatraghavan, and I'm a solutions architect in the technical integrations and developer relations team at Palo Alto Networks. And
Ivan Boyer, we both work at the same team at Palo Alto Networks.
And our focus is all around automation of the VM series capabilities integrated with a lot of our public cloud platforms and even the private cloud ones as well. So I just want to level set. We've heard, hopefully you guys have heard here a lot about automation, right? And the cloud and the need for agility. So I just want to level set and make the case once again, right? So why do we need automation? As application teams continue to deploy their applications and they want to leverage the cloud, it's the reasons to do that is all about agility, right? So your application teams want to be able to go through their life cycle about dev, test, production. They want to do that in a rapid manner because every second delay means an impact on your line of business, right? So you want to be very agile, but also there is also this thought that moving into the cloud can also improve your security posture. So what we have actually done, and we'll talk about all of that, is leveraging all the cloud native capabilities as well as the VM series capabilities actually gives you an increased security posture. It also increases your agility. And also in the bargain, if you could actually reduce all the effort involved to achieve your business objectives, I think that would be great. Automation really helps in those ends. And last but not least, you have everybody talks about DevOps and how do you say, the fact that DevOps and security are not in line, right? But what if we could actually inject security into DevOps and make everything DevSecOps? So this picture that you see here is how all of that is brought together using tools like Terraform, and you can achieve software automation, complete visibility, injected into your DevSecOps process, and achieve cloud success across all the different cloud providers, and tightly integrated with the VM series platform. So you have automation, you have concepts such as infrastructure as code that actually help you accelerate cloud adoption.
Okay, so continuing that trend, you probably, the guys, you've been in a general session and heard that we at Palo Alto Networks really care about automation. So now, I just want to emphasize on what Vinay has said, that down the line, automation is really the only way you're going to be able to fight against cyber and play in the cybersecurity, right? This is just the one angle that we're talking about today. It talks a lot about automation tools and the way you can actually utilize those as a cornerstone to everything else that you can do. But bottom line is that if you're going to do this manually, you're probably going to lose the battle down the line. Automation is key to it. So now, why is that? If you look in a typical cloud journey of the company, going from the on-prem to the cloud, right? They usually start on-prem, then they kind of move into some kind of hybrid solution. They're kind of testing the grounds, trying to figure out what's going on, and maybe eventually they're going to end up fully in the cloud, or at least majority of the services will be running in the cloud. But cloud behaves so much different, obviously, in on-prem. The days when you go and set up your appliance in a data center, plug in the internet cable, and set up the IP and say, okay, I'm done until next refresh cycle, are not there anymore. Cloud moves much quicker. So we've talked to the customers that actually told us that they deploy topologies for disaster recovery or otherwise, the hybrid topologies, where actually they tear them down once a month. So actually once a month they will bring everything down and bring everything up after they applied all the security patches and everything else. If you try to do this manually, you're just going to go insane, right? So the only way to do this is really to automate that process. Make sure it's reproducible, right? Because you want the parameters always to stay the same. So if something goes wrong, you can actually go back, figure out what did you change, and then you basically do it again. Quite often, our customers, if they run into trouble in the cloud, they don't bother trying to fixing it if it takes a long time. They will tear down the whole thing and just instantiate it again. Because it's simple, it's easy. Automation tools help you with that. It's repeatable, right? You can do it as many times as you want. Especially if you're trying to set up the different staging areas. Quite typically you'll see, your pre-production area where you go test your stuff, QA looks at it, internal DevOps looks into it, is pretty much the same as your production area, just with different access privileges. So you got to be able to repeat this, and you got to be able to scale. As a note, Netflix, whenever you watch any of your favorite shows, will instantiate about 10,000 containers for you, only for you. And the average time of those containers going to live is going to be about 5 minutes. So in 5 minutes, this thing goes up and down, right? So how do you scale with that unless you can automate most of the stuff?
Yeah.
Some additional benefits of automation, as Vinay mentioned, there's agility of development, which is, you have your guys who want to churn the code. You want them to create your line of business applications, which actually work. They're just going to do, they do what they're best at, which is they can bring these features. On the other side, you have a security team, and really they don't move that quickly, right? Quite often in the old days, your developers would try to build an application. They would have some requirements around the networking. They would then probably open a ticket with the security guys. They would look at the ticket. They would try to figure out what's going on. It would take them a week, 2 weeks. Anyway, more than a day, more than an hour to figure out what they need to do. It's going to go to review, and only then developers can do something about the code that they're developing. Well, those times have changed. Quite often cloud companies have releases which are every week. So there is no way that these two cultures can collide anymore. However, with automation tools and we can actually mitigate some of these risks. Other ways that also there's also a networking team which needs to figure out, well, how does your network infrastructure looks like, your VPCs, your topologies, can I make sure that I give you this subnet, that subnet? These guys are on the other side of the table too. With automation, you can actually have all these guys still keep the ownership of their pieces. Security guys own the security, network guys will own all the topologies, and obviously the dev guys will actually own the application development. Through automation, and we'll see some of it down the line, you can create the templates for each of these guys, your golden templates, which then you could just merge together and have a composite way to actually deploy applications down the line. And it doesn't take 2 weeks anymore. It can be done in a matter of hours.
Yeah. And yeah, exactly. Just to add to that, right? This just demonstrates the fact that now all stakeholders still continue to have their say. They can review it. It goes through the review process. It's highly auditable. But once you have actually signed off, the action of actually deploying and going into production and going live is just a few clicks of a button, and it's that easy, right? And you can be up and running in hopefully a matter of hours. And last but not least, given that this is a Terraform-focused slide or presentation, Terraform can be used to actually win your multi-cloud, right? You can have a single DSL, a language, and it's highly declarative that you don't have to actually now go and encounter the learning curve to learn AWS CloudFormation templates or Azure Resource Manager templates. You can actually use one declarative syntax to actually define your posture from an infrastructure as code perspective, and with the newly minted Palo Alto Terraform Provider, now you can actually address your security as code.
So actually, one important fact I forgot to mention is that what's very interesting, what we've seen about adoption of your products in a cloud or otherwise, is that it depends where your DevOps culture comes from. So we listed, and this is about Terraform, but there are other automation tools too, right? And it depends on your DevOps culture. The adoption of your product will depend on how well you play with those tools. So you might have a DevOps culture which comes from like a cloud, born in a cloud company, which is like to use a Go language, which they will adopt Terraform very easily. Other side, you might be some of the more mature network security companies, which prefer things like Python. Therefore, they might go Ansible route. It really depends on what you do. However, these are the guys who are going to adopt and evangelize your product. So what we've seen from our side is that we just want to be a Switzerland, to be honest. We want to work very well with all these guys. And down the line, DevOps culture will actually adopt our products and technologies and help us actually have them deployed into your accounts.
Yep. So what I'm actually going to walk you through now is this concept of a cloud security automation stack. Just like we have a networking stack with separations of concerns, and it actually is the building blocks, we're actually going to walk you through something called a cloud automation security stack, which is actually representative of what it actually takes to deploy secure applications and be agile in the whole process. So the first layer of the stack is the infrastructure layer. And so what have we done to actually enable our customers leverage these capabilities, right? We have Terraform Cloud Templates, which allow you to define infrastructure as code. And these are blueprint templates, well architected, that you can actually leverage very quickly. In a matter of minutes, you can actually leverage these templates and deploy applications with following best practices into different cloud platforms, right? So that forms the first layer. This is your infrastructure layer, and here you can now manage it as infrastructure as code. So the second layer of this is now your security layer. Once you've deployed all your applications, you just don't want to open it to the entire world, right? This is where the Terraform Provider, which is newly available from Palo Alto. I must mention that Palo Alto is the first security vendor to develop a Terraform Provider, which now gives you the ability to define your security as code. It's pushed into a repo. It's highly auditable. You can track the changes. You know who made what changes. But more importantly, you can leverage inherent capabilities in the VM series and the Palo Alto platform to now push the security as code in the form of security policies, NAT policies, and other policies enforceable on the VM series. So now that addresses the next layer, which is security layer. So now the work's not done as yet, right? As Lee Klarich, our CPO, mentioned in the general session, the threat landscape and the malicious actors, they're constantly evolving. As Neer also mentioned, it's going from humans to AI and automation, right? So we need to keep abreast of this. So we're also going to now show you how you can define your operations as code and how we integrate into this layer as well using native capabilities and how to make sure that you're protected from an ever-growing threat landscape. And also this other concept of how can you actually push capabilities into your existing infrastructure. So that's the concept of operations, the operations layer, and the notion of operations as code. And last but not least, as you can see now that when you build all these together, these are the building blocks where you can actually build out a repeatable, consistent, agile, and secure platform infrastructure stack that helps you deploy your applications and actually dramatically increase your cloud adoption as you leverage the various cloud providers for your critical applications.
So you could have your product, the best of breed product, but unless you have automation in a cloud, you don't have a solution. That's something really, I think, what's changing in the paradigm that, and some companies are realizing this, like ours, that, unless you can automate your product in a cloud, there's no solution. And it's going to be really hard to do it. Just keep that in mind. That's almost do or die type of thing.
Yep. And all these different layers shows you how you can use repeatable constructs and define all these layers as code and how it can be integrated with cloud native capabilities as well as the VM series platforms on these different cloud environments. And we're going to talk about some of these different layers as we go through. So the concept here that I'm trying to convey is that now it's highly repeatable. This is your stack, and it gives you a highly agile and secure infrastructure on your cloud for your cloud workloads. So let's look at the security automation stack at work, right? One of the predominant architectures that's panning out in the cloud is this notion of transit VPC, right? Where you have a security hub, you define a security perimeter, all traffic that ingresses your assets go through the security perimeter, you deploy your policies, but your line of businesses now reside in separate VPCs, and now you deploy your policies to enable safe and secure access. So let's see how this works out here. So you create your security VPC. Once again, the point here is to reiterate that you can build out using our templates that are readily available to build out your security VPC today in a highly elastic fashion. I've simplified this diagram, but what it doesn't tell you is you can deploy, for example, the VM series firewalls in multiple availability zones. The load balancer will take care of load balancing across these different zones, and we handle the automatic scalability for you. But also the key thing is you can use our Terraform Provider to deploy policies across these VM series firewalls, integrated into Panorama. You have seamless scalability right there. So the next step is to actually help you to define your line of business application. So it's no good to just have a security VPC when it's not doing much, right? So these are your actual line of business assets that you really want to define. So you have readily available templates that allow you to build out these line of business VPCs. But now, once again, these have fine-grained security policies. It does no good because they're independent units. Nobody can access it. The next step is to actually build out this concept of using cloud-native capabilities. Amazon came out with this concept of VPC endpoints. We immediately latched onto that and built out an architecture which showed you can build out this transit VPC leveraging cloud-native capabilities, but also now you can actually have the VM series firewall NAT and forward all your traffic through these VPC endpoints. Great. So this is the fundamental architecture. I want to reiterate that all these aspects that I've just shown you today, There are readily available templates that you can leverage and deploy this particular architecture. So we're not done here now. So that was the first part. So now you have, I talk to customers all the time. We talk to customers all the time. They have anywhere between 10 to 200 applications that they want to build. So now you want to make this repeatable. Each of these applications will be deployed in a line of business VPC. So you want this highly repeatable, right? So once again, that's the point about manual versus automation, right? I mean, anything that you do manual is highly error prone, right? And then you have to resort to debugging. But once you define this capability and you define it in your infrastructure as code and your security as code, you're able to reason with your changes very easily. And now you can actually reproduce it across n number of VPCs. So you have a very automated way to build out this transit VPC solution, arguably, and it's very, very easy to adopt. So the next that previous slide talked about the infrastructure as code and security as code aspect, right? So now let's see how we can incorporate these operations as code into this as well. So this is a representative implementation that we have readily available. Once again, all of this is easily deployable using Terraform. We have templates. You can actually adapt it very easily by tweaking a few parameters. It's that easy to adopt. But the concept here is now these new threat intel sources, right? You want to be able to constantly make sure that your assets are protected against these. So we built out an implementation using cloud-native capabilities once again. But it's always this close marriage between Palo Alto services and capabilities and the cloud-native services. So we leverage Lambda functions, and to actually create, we receive these indications of threat from AWS Guard Duty. It triggers a Lambda function, which actually triggers an operation to create a dynamic address group on the VM series firewall. We actually then leverage that dynamic address group into a security policy. Say any malicious IPs that match this particular dynamic address group, this tag, let's say that we want to make sure that that traffic is dropped or denied, right? So that kind of capabilities, and it's very simple to deploy this whole infrastructure, as you can see. And it's a few clicks using these Terraform templates. Now you have operations as code, and you can see how this is once again highly reproducible, and it gives you that next level of security defense against ever-growing threat vectors.
And the guard duty that Vinay mentioned is just one of the sources we can ingest, right? We have other capabilities and tools like MindMeld, which can actually ingest threat sources from multiple different places, I guess, and combining together, trying to correlate them, figure out what else needs to be done. But this is just one example of how you can use guard duty, right?
Correct, absolutely right. So this guard duty, thank you for mentioning that, Ivan. This is one way of integrating with these new threat vectors. We have MindMeld, and all of this is, at the end of the day, it's finally actionable by creating different types of security policies on the firewall to protect your assets. So here's another concept that is very, very near and dear to my heart. I mean, I'm also a practitioner in a way, and with containers are all the rage, right? So I didn't want to be left out. We didn't want to be left out. So we're going to show you a workflow here where all of these concepts that we've talked about is now easily deployable using containers. A lot of these other mechanisms require infrastructure and canned environments, and then you need to actually now babysit these environments. But now with leveraging containers, you get this incredible agility. So I'm going to talk about how we walk through this whole thing. So this security VPC that we built out in the original slides, so let's build out your perimeter. So you can actually throw out a container job. All of this is available as a container today on a public Docker repo, if you will. You can actually have a YAML file that defines, hey, I want to run this particular container, and I want to run this particular infrastructure as code. Let's say all of these templates are available on our GitHub page. So you can actually run your containers today on EKS or AKS or GKE, and it'll actually go and deploy your environment on whichever your cloud provider of choice. Secondly, you can also adopt a similar workflow to deploy your line of business application. So now you can see how you can use this concept, and another concept that I'm going to talk about is composability, to deploy your line of business application fully deployed using a container, right? The next step of this is, once again, it's the similar pattern, but all of this can be done using containers, and you can set up the private link. But the most important workflow that I want to highlight here is the fact that now, and maybe I'm getting ahead of myself here, but I'll save it. I want to save it for the next slide. But now you can actually deploy and deliver your security policies, your golden configs, to your app teams to say, hey, when you guys are ready, here are the configs that I have validated. These are available to you, and you can actually deploy it, and you can deliver these as a container to your application teams. So once they are ready to deploy their application, they roll out their application, and they can actually roll out the security policies to go with their application. Now, this is okay because it's actually been vetted by the security teams, and they can say that, hey, now you can actually use your fine-grained role to deploy these policies for your application. So the security team is no longer the roadblock, and it gets, you can leverage that agility that the application team really needs. So to summarize here, the benefits of this kind of a model with the distributable container security with containers is agility, self-service for the application teams. It still goes through a vetting process. It's highly auditable, but you're achieving all your goals of security, self-service, and it's highly auditable. So
maybe just if you can go back to the
sure.
slide. So just quickly to add, so just to emphasize again, the separation of responsibility, right? You're not taking any power out of the security teams. You're not taking any power from the developers, right? They still work together, right? Except, as Vinay mentioned, you can deploy a security container, which security team has vetted. It's a golden image. It's a golden container, if you will, right?
Yep.
And app teams really don't care about what's going on with it. They just need to know, as they develop their applications, they just need to develop this additional component, and it's going to take care of the business, right? On the other side, in the Palo Alto networks, you can also create the same containers for the app teams. And as they develop their applications, right, they can actually have their own security containers, which allows them, as they develop applications, to actually have access to the same. So like in what we've seen, from the practices with our customers, security team will go and set up like pre and post like firewall rules that never change, kind of catch-all rules. For example, they're going to say you can never run FTP protocol, for instance, right? Within those rules, apps teams can actually deploy their own app containers, security containers, which allow them to say, okay, well, I don't really care much about FTP. I'll never do that. If I do, they're going to catch it. But I want to have a choice of whether I run my web application on port 80, port 880, somewhere else. And therefore, they get their agility. They can try things, test things, produce things, turn them. And security teams still has a complete ownership about saying, well, you will never in my company run FTP.
Yep.
That never changes.
Yeah, absolutely. And that segues into this next slide, and I'm going to request you to humor me as I walk you through this. But it's this dance between DevOps and security, right? I think a lot of you know where I'm going with this. So on the left here of the screen, you have arguably F-16 fighter pilots. They're highly agile. They move very fast. And so that's all great, But on the other hand, you have this B-52 bomber that doesn't move as fast, but it also serves a very critical purpose in the whole arsenal, if you will, right? So if I was to ask you where I'm going with this, what do you think? Who's who? If you were to attach personas to this, who do you think? Oops, my bad. It got ahead of myself here a little bit. But who do you think are the F-16 pilots, if you will, from an application deployment lifecycle? And I'll just answer that anyway. I think it's the app guys, right? They want to move fast, they want to leverage the latest capabilities, and they want to be really, really agile. But at the same time, the security teams need to establish these guardrails. They have a place here. They need to oversee everything. But the point that I'm trying to make here is the fact that what if we made the security guys a little bit more agile, a little faster, and to meet the requirements of the app teams, if you will. And I want to take it a little step further to actually say now, with the concept of drones, right? This is the concept of distributable security with containers. So now you put the intelligence, you put your blueprints in these containers, and actually you deliver it to the app teams, and they can, when they're ready, they can actually deploy it, and it actually really, really provides that agility that both DevOps and security can have a great relationship, and the winner is your line of business, right? Ultimately, that's the key driver for a lot of these workflows.
And obviously, it's all stealth.
Yes.
I mean, your app guys really don't know that there is actually security constraints and guardrails being enforced on them, because they don't have to care, and they probably don't have to worry about it, right? Anyway, but those exist. Those guardrails exist, right?
Yeah. So the whole point of this slide is to show that now your app teams and your security teams can really move together, really move fast, and you can deploy and you can adopt the cloud in a secure manner by adopting a lot of these workflows. So to that end, let's talk about this use case, and I'm actually going to show you a demo of this use case. So on the top, what you have here, my bad, is you have your app teams that are using different types of CI/CD tools out there. In this particular case, I'm actually using AWS Code Deploy to constantly deploy new versions of an application into their cloud environment, right? But at the same time, that you have your security teams that need to actually provide the policies to make sure that that app is exposed in a secure manner with all the inspection thereof, and to make sure that the right security policies are in place. So we as a community still have this one handshake that needs to happen. There is a conversation that needs to happen between the app team and the security team, that we're constantly innovating in that aspect. But once the app team says, here are my requirements, here is the requirement for my app to be exposed and to be usable by my users. So once he conveys that information to the security team can now be agile. So what happens here is, as soon as the security team gets the requirement, now they are very agile as well. All they do is now they represent their security policies as code. Maybe they use a private GitHub repo, for example, push their code to their GitHub repo, which is picked up by Jenkins, which is a frequently used CI/CD tool, and then seamlessly deployed into the VM series firewall. And this gets represented as NAT policies, security policies, threat policies, what have you. And so this shows you the agility and how DevOps and security and DevSecOps actually works very well in deploying applications at a very fast pace. So the app teams push their code, the security teams are able to react in a similar way, and they're no longer the roadblocker. And then now this is a continuous process. Let's say that this is your dev, test, prod. It's highly repeatable. You've tested your configurations, and this seamlessly gets deployed, and your applications get the agility, and the security teams are satisfied with their processes as well. So once again, all of these leverage these automation capabilities that I just talked about. Now, how do you might ask this question, how does the security team achieve this kind of agility? This is crucial here, which is using our either Ansible templates or Ansible playbooks, I beg your pardon, or our Terraform templates. Using our Terraform provider, and I'm actually going to show you a demo of this, the security team now comes and makes a few changes, pushes it into their repo, it's been validated, gets picked up by the CI/CD system and pushed out seamlessly.
And obviously this can be simplified even more. I mean, we have some of the tools, technologies that we have for demos we've seen people use. I mean, your security team could be depending on ServiceNow, which actually opens the tickets, which ports needs to be opened, which automatically use our Ansible to actually opens up the ports on the firewall. Or you can pick up any technology that can do API integrations, or can run scripts, and you can just replace any of these icons with the technology, and it just works. So you can really natively fit in almost any flow that the customers use. And for those that don't, well, we'd like to know about those. So we can cover that too. But so far, I think we have pretty good extensibility with our tools to actually fit in any workflow you need to have in your enterprise.
Yeah, and just to reiterate this concept, a few points to just reiterate here is this ability for security teams to not be reactive, they can be proactive. They have the ability to define security as code. It gets deployed as necessary. App teams continue to be very agile, and it's just a very seamless process to deploy your line of business applications. So I was actually going to do a live demo today, but I'm not able to connect back into my corporate environment. But I'm going to run through this demo using a video.
Just give some time. Somebody just set up those security policies here, so we can't actually connect to the mothership anymore. What's up with that?
Oops. All right. So it's sad. I was able to do a live demo here, but essentially this actually ties in all these different concepts together. So maybe I'll just highlight all the different aspects. So what you see here are these Terraform templates that are readily available for you guys to leverage. These are available on our Git repos. And I'm actually going to deploy a two-tier application on AWS, right? So when I refer to a few clicks, this is literally it, right? And I'm going to actually show you how we deployed. So this is a post-deployment. I've actually deployed this entire stack on AWS. What it does is actually creates all your VPCs. It creates all your subnets. It creates your untrust subnet, your trust subnet. It deploys the Palo Alto firewalls. And it configures, it gets bootstrapped. It configures default policies. And so I have a website that is exposed behind that on the data interface. Now let's look at, I also want to demonstrate the zero trust, right? So when this comes up, there are no policies, there are only default policies on the firewall, which is pretty much allow outgoing egress traffic. But as we walk through it, here it shows you how what exactly the Terraform template deployed. Can you all see this? Is it too light? But so now here, this is the deployment on the back end. It actually deployed a firewall, a couple of back end servers. This is the public IP. So now we're actually going to, I believe, introspect the firewall and the rules that have been deployed on the firewall. So let me show you that. So
We like to use dark backgrounds because that's cool.
yeah, so this is the firewall that we have here, and I just want to show you that currently there are no policies on the firewall, so your backend application is actually not accessible, right, until the security team comes now and actually deploys the right firewall policies. So we have a few default services. These are all the default configs that our firewall comes up with as part of the bootstrapping process. So in the next video, what I want to show you is now we're actually going to deploy. I want to add the capability to expose that particular service on my firewall. And this is a security persona, if you will, right? So we're actually going to push these security policies defined as in a Terraform file. We're actually going to push it into Git. I'm actually doing a Git commit over here. We give it a commit ID. So I push it to my Git repo. And so as you can see, these are the changes that you see on the on my Git. But what happens is I have my Jenkins server that's constantly looking at changes on this particular repo. And as soon as it sees these changes to these policies, it will kick off a job to actually deploy the new policies onto the firewall. So this is a view into the Git console. It notices there are changes. So long story short, it picks up the changes. It creates a new job right here. So it actually uses the Terraform Provider and the policies to interact with our firewall, deploy all these new policies on the firewall. And if I go ahead, you can see that there was a commit that was just happening. Once it's committed, we'll see the new policies that were deployed on this firewall. There you go. So this is the first this is the first step in this, right? Which is the first application that we deployed. So you see how seamlessly you just deployed all this code. you defined your policies as security as code, you pushed it to Git, it automatically got picked up and it got deployed into these firewalls. That's all the security team had to do. They just had to push their code, very similar to what app developers would do to push their application code. So now if I was to actually curl this website, you could see that the backend web server is accessible. So next what we are going to do is show you how this gets integrated with AWS code deploy and part of the CI/CD process. So this video here walks you through how I've defined a new application. So now I want to deploy a new application, which is this concept that I keep talking about, where application developers want to deploy new applications on a regular basis. So they actually go and create a new deployment. So I'll be creating a new deployment here. I have a new version of an application. I pointed to a GitHub repo. So this is the application developer persona right here. So what this does is it actually picks it up from a Git repo and it pushes. So this is the AWS code deploy workflow for an application developer. You can specify a specific commit and it will go and deploy that application. Now, the important thing here is, as I'm going to show you, I've exposed that application on port 81, and this application is not accessible, as you can see here, right? Because the security policies have not been deployed as yet. So now what I'm actually going to walk you through is my actual Terraform file where I have defined those security policies as security as code, and I'm making the modifications necessary to actually enable secure access to this application. And I'm actually going to push this code, and that's all I'm going to do. As the security practitioner or the security ops guy, I'm just going to push code. Now it's just that easy for me using the Palo Alto provider. And here's what I do here. I'm literally going to, I'm showing you the diff here. Here are my new policies that I want to add into my firewall. And I'm going to push these policies into my security repo. Right? So I'm committing here. Policies for new line of business. As you can see, I'm deploying new policies for this line of business application, and I push it to my repo. Once again, as you can see, I have another job that's constantly polling this particular Git repo for changes. As soon as these changes are made, my other Jenkins job is actually going to pick it up, and it's going to seamlessly deploy the policies for this new line of business application. If you could bear with me as I walk you through this there. So this is literally the changes being picked up in Jenkins. It actually interacts with the firewall. It deploys the new policies. And we have committed it. Now we'll go back and look at the new policies on the firewall. These were the old policies. I'm going to refresh it. All the commit is still executing. Once this is done, you'll see all the new policies for this new application. As you can see, I have new policies for web traffic 2, SSH 2, and now this application is now going to be accessible. Right? So I've just deployed another application. So I hope this surfaces the fact that now you can see how application teams continue to deploy their applications. They have the conversation with the security teams. This could even be done prior, right? So that's the advantage of this. So once that is done, the security teams go and deploy, have their security policies, and then this also dovetails into that container workflow. And now security and app teams are able to deploy line of business applications in a rapid manner. Ivan, anything else to add to that workflow?
No, and just to kind of reiterate, I mean, we did videos that was going back and forth, but this whole process happens pretty much automatically.
Yes.
And it's a matter of, I don't know, when you time this, like how long does it take for something this to finish?
Less than a minute.
Less than a minute. Okay, so I mean that happens pretty quick, right? So I mean that's the agility that everybody wants to have. And unless you can provide something like that, there is no way that you can actually keep up with the features, especially when you move into the cloud, right? But again, in order to make this all happen, you have to have these automation tools.
Yeah.
Which we do. So I think that's the crux of the story.
Yeah.
That, otherwise this would take probably weeks to get it all done. And they're just not quick enough for anyone.
And then the concept goes back to that security automation stack, right? You have templates that clearly define your infrastructure layer. You have templates as infrastructure as code. You have templates that define your security layer as code. And then you have templates that define your operations layer. All of these are available to you guys to use today. We have a page, which I'll talk about soon. And then it all really, really dovetails into making DevOps more DevSecOps. Right?
And if you think about it, for any of you that actually dealt with this, where you had to put at the same table a security guy, an app guy, and a network guy, and have them talk and have a beer, this helps you do that. Because they will all come with their own beer and still have the talk with you. But it works. And that was like really the major barrier when we get into try to deploy some of these technologies, that how do you put these two guys together? And it's really tough because they have completely colliding objectives and what they need to do. Well, with this, having them all own their own piece, but then you put it together in a composable way, this is a winner. This is how it works.
Yeah. And lastly, we just want to summarize a lot of these workflows that we've talked about, right? I liken this to building like some kind of a big structure, right? So you first need to build out the foundation, which is provided by the Palo Alto Network's VM series platform and the native capabilities, right? We leverage a lot of the capabilities of the Palo Alto platform and the ability to work very closely with cloud native services and to provide a comprehensive security platform. So let's build out these pillars, right? We have infrastructure templates that build out all these different types of blueprint, best practice architectures. We have cloud native templates that integrate with cloud native capabilities such as guard duty, VPC endpoints, so that allow you to build out these cloud native tunnels. We have this Terraform Provider, using which you have this ability to represent your security policies as code and really leverage DevSecOps. These things are highly extensible. They have loosely, very clearly defined, but loosely coupled architecture, which leads us to another aspect, which is the ability to compose. When you want to win in the cloud, you can't build out these tightly coupled solutions. But what we've actually built out is a very loosely coupled architecture that allows you to use different building blocks to build out the right security posture for your applications on various cloud platforms. And lastly, the cupola is now you're able to achieve cloud success with security, right? And that's the key. So hopefully, to highlight some of these key takeaways, Ivan.
Well, so this is actually not all pipe dream. Like the development and security container that what we showed you is actually already being deployed and in production with some of our customers. You can actually go and access any of these GitHubs, right, repositories today and use them too. And we can also talk, obviously, we're always available to talk about, how do some of our customers use some of these, because they do, it's in production.
Yep.
So it's a real world, as the second bullet says. This is not something that we just imagine, right? And it's really adoption of these technologies and these practices is really skyrocketing, like going exponential. Because everybody figures that, this is the only way I can survive here. Otherwise, I can just, pretty much go lock myself up in a room, right?
Yeah, and my last comment before we'll open it up for some questions is all of these are readily available for you guys to use. We have a live page which is called live.paloaltonetworks.com/templates. So you can access all of these templates. These are built on best practices architectures that have been built in collaboration with a lot of customer feedbacks, solution architects from the different cloud providers. So these are vetted architectural patterns, if you will, that you can leverage very easily. I want to say in a matter of minutes. And then hopefully it allows you to be very, very agile as your organizations adopt the cloud for your applications. So with that, we'd like to open it up for some questions.
Actually, live.paloaltonetworks.com/cloud template.
Thanks, Matt.
So yeah, so it's not
Yeah, I'll
just
repeat that.
yeah.
So my bad. The link is live.paloaltonetworks.com/cloud template. One word. Yes.
So the security as code piece, to create the rule within Terraform, you still need some sort of security engineer to create all that, right?
Mm-hmm.
Some type it up manually. We have done all security rules via Terraform and AWS. So we're looking at doing it on the Palo side. Our SLA for getting everything done within AWS is 24 hours.
Mm-hmm.
But that's still not enough for DevOps.
Mm-hmm.
They want it within 1 hour.
Okay.
So, you know, you mentioned if we feed that information from ServiceNow,
Yeah.
we're looking at ways to insert that information and consume that information such that the Terraform file already gets created. Now, to do that, we still need guardrail checks. For example, I don't want any port from any in any of my rules. Right? Where do you see that piece being inserted? Is that within Jenkins? Do you have any customers doing that? Or are they leveraging Terraform Enterprise to insert that with Sentinel?
Yeah.
So I'll give you my take on it, and we should talk more to really understand more what's going on. But you know, you mentioned that you don't want, if you want to check for some rules, which is based on sort of practices within your company, so you don't want to allow for any-to-any, that's the check I would do on your side. You know, if you want to actually now make sure that all these ports are being automatically injected into your Terraform template, as you mentioned, you could use something like Jinja or templating mechanisms. Pull the, we have another demo of it, not for this session, for the other session, where actually we can extrapolate data from the application metadata itself, which you then push automatically into the template itself. So developers don't do any of their job. It's all automated, right? They have no access to this. I will go look into, I'll give you an example if you're familiar with Docker files. I can look into Docker files, see which ports is being exposed. Pick that port, and that's the only port I'm going to enable and open up in my Terraform script. Developer has no access to that. They can't do anything about it. This all happens automatically for them. So that will be one way to enforce it. So now you asked about, do I want to be able to enforce any-to-any, which is kind of the practice on your side that they need to enforce. Well, that has to be done on some sort of review on your side, right?
Where do you see that piece being enforced, though? Do you see that enforced?
Oh, right. So you mentioned ServiceNow. So if you would do it through ServiceNow, I would enforce in ServiceNow in your fields and say, okay, that this particular form in ServiceNow does not allow for something like that. If you're going to do it through, like I said, introspecting the metadata of your application developer application and then trying to figure it out, I would enforce it there. But it depends on what's your process. If you use some other tool, that would be a good place to do it too.
Yeah. Exactly. Yeah.
So do you provide any tool that can read out of the firewall about your rules and then generate the Terraform template automatically? Essentially a reverse engineering tool.
Yeah.
Yeah. No, a simple answer is no, but we are thinking about those kinds of use cases.
So we do have a product called the Explorer, who can actually generate rules out of the other firewall rules. That the Explorer itself could potentially generate anything else. This is not on a roadmap right now, but we've been thinking about exactly what you said. And this would be probably the right way to do it for us, because we have all the pieces already there.
Yeah, that's true. No. So the question is there a Terraform module for Jenkins? Yep. Yep. Right. Yep. Yeah. So in this particular use case that I just showed you, so for example, your Jenkins has the Terraform module. It's able to automatically, I had a polling job that actually is looking at my security repo for my security as code. Any changes to that security as code, Jenkins pulls the latest changes, and using the Terraform module, it applies those changes on the Palo Alto firewall. So that's the current workflow. So are you asking for a different workflow?
So if I can, so you can potentially execute from your Jenkins any external script, one of them being Terraform plan. However, we are thinking about writing a Palo Alto Jenkins plugin, which will potentially skip through all of that. And then you could do exactly what you're saying, which is go from Jenkins directly to our devices. There hasn't been that much need because everybody was very happy just putting another kind of shim in between, which is Terraform in this case, right? It's just a matter of time and how many actually customers ask for it, right? But that would be a way to do it. You just write Jenkins plugin and then go with that. Yeah. 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 Yeah.
Yep. That makes sense.
Makes sense, yeah.
Yep. Yes, sir.
How exactly are you going to solve the shadow business? So today, with this process you want to explain, we can add multiple rules and have the rest of the rules that we don't do that. But let's say there's a shadow business, which is pretty broad enough, say HTTPS to all these little Terraform environments that are maybe from some problems to your own problem, because they're not by default, but somehow there's the management document where you have to do that request and you have added rules. So there's a pretty good chance that we keep adding multiple rules, but there's also a shadow which covers all that. So there's a lot of unused rules sitting in the firewall that you don't space there, right? So there are some limits to where each one utilize. How exactly solve that?
Go ahead.
All right, so let me, yeah, so that happens a lot. But it doesn't happen as much with our firewall as with the others. And the reason why is that actually our firewall will tell you if you're shadowing. So if you set up rules like that in our firewall and looking at it, it's going to tell you this shadows this. So you can fix it. So now, there's also the Explorer, which I mentioned, the tool which actually picks up these configurations from the other firewalls and stack them into our firewall. Actually, that tool will do actually many other things, including double check there is no redundant rules, including also compressing rules, like 1,000 rules from some other firewall into ours, simplifying them. So you could run that on a side as a process which actually do these checks whenever and as much as you want, and potentially even remediate it immediately. So you could do that. That's one way to do it. It's called Explorer.
Expedition.
Sorry, Expedition. Right. Yeah. So I'm sorry. Yeah. 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 So, thank you, Matt. It's called Expedition, and I need some food as soon as possible. Yes. Right. Yeah. But that would be a way to do it, because this tool is also, you could just run it on the side through another pipeline and just keep doing this like as frequently as you want. So now, one thing I did mention is that you can always assure that you can't go out of your boundaries, because you can create post or pre-rules that never ever anybody changes but your security guys. So whatever happens in between can potentially overshadow each other, but you always have catch-all, which says, again, simplified example, you cannot use telnet ever. So even if you after that say, okay, you can use telnet, you're still, kind of in a chicken or the egg situation, which actually you are egg or chicken, I don't know, whichever first.
Whichever came first.
It's lunch.
Oops.
I started making jokes, right? Yeah, thank you. Yes. Any other questions?
Okay, I think.
Okay, far from. Very good.
Well, I think we hit our top of the hour. So thank you, everyone. Thanks for your time.
Yeah.
Hopefully this was interesting. And if you have any further questions, we're happy to engage and help you through this process. Thank you.